Uh, a group of 630 children is seated in rows for a group photo session. Each row contains 3 less children than the row in front of it. Which one of the following number of rows is not possible? Okay, so I assume maybe this is x, then this is x minus 3, then it is x minus 6 and x minus 9, and I assume the last one total and rows are there. So and second, this is 1 time 3, so in last, okay, so in the last row these many students are there. Okay, and how did I get this n minus 1? See, in the second row 1 time 3 is there, in the third row 2 time 3 is there, in the third row 3 time 3 is there, so in nth row n minus 1 time 3 will be there, right? So total of all these should be 630. So I'm having n rows, so x n times nx, plus if I take this 3 common, then inside the bracket I'll be having 1 plus 2 plus 3 till n minus 1 time, right? And what is the sum of first n minus 1 natural numbers? That is n minus 1 n minus 1 by 2, right? Sum of first n natural numbers is n plus 1 by 2, but I have to find out the sum of first n minus 1 natural numbers. So n will be substituted by n minus 1. So n minus 1 by 2, that is the sum of first n minus 1 natural numbers, right? So 3 plus 6 plus 9, I took 3 as common. So inside the bracket it is n minus 1 by 2, and that should be 630, right? Because total number of children are 630. Now from the options we have to find out which number of rows is not possible, right? So what we can do to make it very simple, we quickly use the options, right? Suppose I put up n is equal to 3 and I just see whether it is possible to have the integral value of x or not. So if you are able to get the integral value of x by putting n as 3, then it is possible to have 3 rows. Okay, if we are not able to get the integral value of x, if we put n is equal to any of these numbers, then that number of rows is not possible. Okay, so suppose I put n is equal to 3. So this is 3x and this is 3 into 2 by 2. So into 3 into 2 by 2, 2 and 2 cancel. So definitely x will be an integral value because this is 3, 2 will be cancelled. 630 minus 9 will be definitely divisible by 3. So x is definitely integral if we put x is equal to n is equal to 3. Okay, and suppose we put n is equal to 4. So this is 4x, then this is 4 into 3. So I have 3 2s are 6, 3s are 18. 18s, if I deduct 18 from 630, I'll be getting 612. So 612 is definitely divisible by 4. So still in this case we'll be getting an integral value of x. Okay, now suppose I take maybe 5. So 5, this is 5 into 4 by 2. So 5 2s are 10, 3s are 30, 30 definitely divisible. Then suppose I take 6, so this is 6x plus 3 by 2 into 6 into 5. Now 5 3s are 15, 15 3s are 45, right? If we deduct 45 from 630, we'll be getting an odd number, right? So odd number will definitely not be divisible by 6. Okay, so in this case you will not be getting an integral value of x. So 6 rows or 6 rows are not possible, right? So this is the correct answer, and I hope you are clear with the concept. Important thing to understand over here is why we are looking for the integral value of x. What I have assumed in the first row, x children are there. Now I am talking about x children. Now number of children cannot be a fractional value, right? So number of children will be either 2, 3, 4, 5, 10, 20. It cannot be 20 and a half, 30 into 30 by 2 or something. 30.2 and something like that, right? So x should be an integral value. So if you have 6 rows, you cannot have x as integral value, right? So clear? A gardener increased the area of his rectangular garden by increasing its length by 40% and decreasing its width by 20%. The area of the new garden is. See, when we have to see the percentage increase and decrease, whether you have a rectangle, whether you have a square, you can take both the dimensions to be same, because from calculation point of view, it really doesn't matter. Okay, so to make the problem very simple, what I do is I take length and breadth, both of them, initially to be 10, right? So initial length, breadth, both of them are 10 and area is 100 obviously. Now length is increased by 40%, so the new length will be 14. 40% we are increasing, so new length is 14, and width is decreased by 20%, so the new width is 8, right? So initially the area was 100, now it is 12, so very easily we can say it is 12% increase, right? So it has increased by 12%, right? A straight line segment is 36 centimeter long. Points are to be marked on the line from both the endpoints. From each end, the first point is at a distance of 1 centimeter from the end. The second point is at a distance 2 centimeter from first point, not from the beginning but from the first point, and the third point is at a distance of 3 centimeter from the second point, and so on. If the points on the ends are not counted and the common points are counted as 1, what is the number of points? So that's pretty interesting question. Suppose this is the starting point. From this 1 centimeter, the first point is like this is 1 centimeter. From this point we have the next point, that is 2 centimeter from this, right? That means this is 1 and this length is 2. That means this point is 3 centimeter from the beginning, right? The next is 3 centimeter from this point. That means it is 3 and 3, 6 from the beginning, right? So precisely what is happening, 1, then 1 plus 2, then 1 plus 2 plus 3, next will be 1 plus 2 plus 3 plus 4, and so on. So next point will be 10, I'm adding 4 to it, then 10 plus 5, 15, then 15 plus 6, 21, then 21 plus 7, 28, 28 plus 8, 36, right? And this is actually point B. Right? So from this side, how many points we are marking? 1, 2, 3, 4, 5, 6, 7 and 8, right? But we don't have to count this because if the points or ends are not counted. So 1, 2, 3, 4, 5, 6, 7 points from this side, right? Similarly, we mark 1, 3, 6, 10, 15, 21, 28, 36 from this end, and once again we'll be getting the same 7 common points. Again 36 will be over here, so we are not going to count them, right? So in all we are having 14 points, but one more condition is there. The common points are counted as 1. That means if while marking these points 1, 3, 6, 10, 15, 21, 28, 36 from this way and the same from this way, if any points are coming on a common point, then we need to treat them as 1 only.